Hi Year 11, hope you're all well. Welcome to our last lesson for Christmas. So as a very special Christmas treat, here's a picture of Santa Claus for our Christmas themed lesson today, or Father Christmas, or St Nicholas, you prefer. Can you make sure you write the title today, please, which is Rationalising Denominators. Our last little lesson on surds. I know it's been a bit of a sort of surd heavy week, but hopefully you feel like it's done well. I did pick it especially for a topic at home, so hopefully you've done okay. Last lesson on it today, Rationalising Denominator, 17th of December. Here's the main sort of core thing of what we're going to do today, rationalising the denominator. We like to not have surds on the bottom of a fraction. We like to have rational numbers on the bottom of a fractions, like integers or even decimals, but we don't want surds on the bottom of a fraction. So when we see them on the bottom of a fraction, we do something to the top and the bottom of the fraction to cancel it so it's not a surd on the bottom of the fraction anymore. So if I have 5 root 7, I can take 5 root 7 and times the top and the bottom of that fraction by root 7. Because if I times the bottom of the fraction by root 7 times root 7 is going to give me 7. And I times the top of the fraction by root 7, it becomes 5 root 7. So this is equal to this, they're equivalent fractions, but the key thing is now, because I've times the top and the bottom by root 7, the bottom is now a rational number. Here's another one, 4 over 9 root 5. Again, I'm going to times the top and the bottom of the fraction to cancel out this surd, and I'm going to times the top and the bottom by root 5. So if I times the bottom by root 5, well, the root 5 times the root 5 is going to give me 5, but it's also being times by 9, so it's going to become 45, and the top of the fraction is going to become 4 root 5. Again, by multiplying by this square root again, it's cancelled the square root, and now I've got a rational number on the bottom. One more normal rationalising denominator then. I've got 3 root 6 plus root 5 over root 2. Well, I don't want that root 2 on the bottom, so I'm going to times the top and the bottom by root 2. That means the bottom is just going to become root 2 times root 2, which is 2. I need to multiply the top by root 2 though as well. I need to times the whole thing by root 2. Well, 3 root 6 times root 2 is 3 root 12. And root 5 times root 2 is root 10. But there's still one more thing I can do to make this better. Have you spotted it yet? That's right, root 12 or 12 has a square factor. So I can keep it over 2. I can keep this as root 10, but root 12 has a factor of root 4. So let's just go up here for a second, just because I've not got much space up there. Root 12 equals root 4 times root 3, or 2 root 3. So back here I've got a bit of space. 3 root 12 is the same as 3 times 2 root 3, or 6 root 3. But again, the key point was I didn't want the surd on the bottom, so I times the top and the bottom of the fraction by that surd again to cancel out the square root and to get me back to that number. Okay, that's the main topic for today. So spend about 10 minutes, please do come back to me in a minute, but just spend about 10 minutes on question 16. 10 minutes on question 16. Make sure you mark your answers as you go and then come back to me. Okay, hopefully you got on okay with that. It is Christmas. Our last lesson for Christmas, so here's a picture of the snowman. Classic, I think it's a book, but classic short film. Okay, expanding these brackets. This might seem like I'm going off and doing something slightly different, but it does link back to rationalising the denominator, as you will see. We did some expanding brackets yesterday, okay, and we're going to expand these brackets. Now you might notice these as difference of 2 squares. We did some work on difference of 2 squares in normal expanding brackets, and they are significant in rationalising the denominator, as you will see when you do these. So I'm going to still do FOIL when I expand these brackets. First 2, 7 times 7 is 49. Outside 2 7 times minus root 6 is minus 7 root 6. Inside 2, root 6 times 7 is plus 7 root 6. And last 2, root 6 times minus root 6. Well, root 6 times 6 is 6. So root 6 times minus root 6 is minus 6. And then if we look, when we simplify this, we've got 49 minus 6 is 43. And then I've got minus 7 root 6 plus 7 root 6. Well, minus 7 root 6 plus 7 root 6 is just 0 root 6 or 0. So actually, when I expand and simplify that, it just simplifies to 43. Have a look at one more then, another difference of two squares. Again, I'm still going to do FOIL. First 2 root 5 times 2 root 5. I have to do these carefully because you can trip on them if you're not careful. 2 times 2 is 4. Root 5 times root 5 is 5. So it's 4 times 5 is 20. Outside 2 root 5 times minus root 10. Well, root 5 times root 10 is root 50. So it's going to be minus 2 root 50. Inside 2 root 10 times 2 root 5 is going to be plus 2 root 50. And then last 2 root 10 times minus root 10 is just going to be minus 10. And again, have you spotted what's happened here? 20 take away 10 is 10. Minus 2 root 50 plus 2 root 50 is nothing. So it just simplifies to 10. The surd disappears. Okay, so 10 minutes doing some expanding double brackets like that. Question 15, I've tweaked the order again today slightly just because I like to be awkward like that. But the order on the slides is the order you need to do it in. So question 15, 10 minutes on that, and then come back to me for our last part of 2020. Okay, I hope you got an okay with that. Last thing for today then. Oh, it is Christmas. So here is a picture of a nativity scene with a particularly zen looking baby Jesus there. Very, very chilled. Not sure what instrument that man's holding. A lamb, I think. Last one then. Last bit of surds. I'm sure, well done if you stuck at it this far. Really well done. You're going to have surds nailed down, and that's going to be extra marks in our next set of papers. Rationalise the denominator of 10 over 10 plus root 3. Well, I can't just times 3 by root 10, because if I times 3 by root 10, that will disappear, but then this will become 3 root 10. So we're going to use the difference of two squareds work we did a minute ago. So I'm going to take my 10 over root 10 plus 3, and I'm going to times the top and the bottom by the opposite difference of two squares to this to make it cancel. I'm going to times the top and the bottom by root 10 minus 3. Because if I times the top and the bottom by root 10 minus 3, hopefully it should cancel. So if I times the top by root 10 minus 3, well, 10 times root 10 is 10 root 10. 10 times minus 3 is minus 30. And then the bottom is going to be 10 plus root 3 times, root 10 plus 3 times root 10 minus 3. Root 10 times root 10 is 10. Root 10 times minus 3 is minus 3 root 10. 3 times root 10 is plus 3 root 10. And 3 times minus 3 is minus 9. And if I simplify that again, my top stays as 10 root 10 minus 30. 10 minus 9 is 1. Minus 3 root 10 plus 3 root 10 is nothing. So it's just 10 root 10 minus 30 over 1, or just 10 root 10 minus 30. So you do the difference of two squareds. Whatever this is, if it's got a plus, you do the same, but with a minus. Or if it's got a minus, you do the same with a plus. Times the top and the bottom, and it should times the third. Disappear the third. Really good work with that, guys. Really well done if you stuck at it this far. Just spend another 5 or 10 minutes doing a few of those from that last slide. I can't remember what the question number is, but it'll be on that last slide there, and mark them. And then have a lovely couple of weeks, and I look forward to hopefully seeing you happy and healthy in January. Have a very Merry Christmas. Hope Santa brings you everything you want if you've made it this far through, and I'll see you in the new year.